From the very beginnings of human history, climate has been far more than a backdrop to the drama of civilization. It has acted as both stage and director, shaping the conditions in which our species evolved, adapted, and ultimately flourished. To understand the foundations of civilization, one must first appreciate the profound influence of Earth's ever-changing climate systems. Governed by the interplay of solar energy, atmospheric composition, ocean currents, and the subtle tilt of our planet, these systems have dictated not only where water flows and crops can grow, but also where people settle, how societies are organized, and what kinds of tools and ideas emerge in response to environmental challenges. The story of our species, Homo sapiens, is deeply entwined with the climate shifts that swept across ancient Africa. Fossil records and the work of paleoanthropologists reveal that major leaps in human evolution, including the development of bipedalism, the crafting of the first tools, and the remarkable growth of our brains, often coincided with periods of significant climate change. Rather than evolving in a single, stable environment, our early ancestors faced dramatic swings between wet and dry periods, forests and grasslands, abundance and scarcity. This environmental instability did not merely test the limits of survival, it spurred the emergence of traits that would become quintessentially human. One hypothesis that has gained traction among researchers is the variability selection hypothesis. This theory challenges the older idea that our evolution was simply a response to life on the African savanna. Instead, it proposes that the unpredictability of the climate, the abrupt shifts, and the need to adapt to rapidly changing surroundings favored the evolution of flexible, innovative, and sociable hominins. Traits such as large brains, capable of complex thought and problem-solving, and strong social bonds, necessary for cooperation and sharing knowledge, may have first emerged as survival strategies in an uncertain world. As evidence, scientists point to oxygen isotope records captured in ancient sediments, which chart the waxing and waning of rainfall and temperature over millennia. These records reveal that periods of heightened climate variability often aligned with bursts of evolutionary innovation. But climate's influence did not end with the dawn of our species. As humans spread out of Africa and into new territories, they encountered a mosaic of environments, some lush and forgiving, others harsh and demanding. The capacity to adapt quickly, to modify tools, strategies, and even social organization became a hallmark of humanity. Archaeological research supports this view, showing that ecological changes driven by shifting climates played a significant role in pushing populations to migrate, mix, and innovate. For instance, the ability to walk upright freed our hands for toolmaking, while environmental stresses may have encouraged the development of language and more complex forms of cooperation. The rise of agriculture, and with it the emergence of civilization as we know it, owes much to an extraordinary period of climatic stability. For tens of thousands of years, humans lived as hunter-gatherers, responding to the rhythms of the land, the migrations of animals, and the pulse of seasonal rains. Then, around 11,700 years ago, Earth entered the Holocene, a geological epoch marked by relatively mild and stable climate conditions. This stability was unprecedented in recent history and proved crucial for the domestication of plants and animals. With the seasonal cycles of rainfall and temperature settling into reliable patterns, communities could plant seeds and expect a harvest, store surplus food, and begin to build permanent settlements. Major river valleys, such as those of the Nile, the Tigris and Euphrates, the Indus, and the Yellow River, became cradles of civilization. These fertile floodplains provided not just water for crops, but also a measure of security against the uncertainties of nature. Ancient cities and empires rose in these regions, their success closely linked to the predictable flows of rivers and the generous yields of their fields. As paleoclimatological research has shown, the stabilization of climate during the Holocene was instrumental in allowing agriculture to flourish and, in turn, supporting the growth of complex societies. Yet even the most robust civilizations remained vulnerable to changes in their environment. The same climate systems that enabled prosperity could, with subtle shifts, bring about hardship or even collapse. Sediment cores, molecular fossils, and other paleoclimatological tools now allow scientists to piece together the environmental histories of ancient societies. These records show that the fortunes of civilizations such as the Mayans, Akkadians, Vikings, and the people of Rapa Nui, Easter Island, often rose and fell with the moods of the climate. In some cases, prolonged droughts or sudden cold snaps disrupted food production, undermined economies, and set off waves of social unrest. The collapse of the Akkadian Empire, for instance, has been linked to a sudden aridification event that turned once fertile lands into inhospitable deserts. The story is not one of simple cause and effect. Climate was rarely the only factor in the rise or fall of a society. Social structures, technological innovations, political decisions, and external pressures all played their parts. However, when environmental stress reached a tipping point, even the most sophisticated societies could find themselves unable to adapt quickly enough. The history of the Khmer Empire, the Mayan civilization, and others illustrates how climate disruptions, such as changing monsoon patterns or multi-year droughts, could strain the delicate balance between people and their environment. Climate's influence is not limited to the material aspects of civilization. It reaches into the heart of cultural identity, shaping economic activities, belief systems, and social organization. The Inuit, for example, developed traditions and technologies uniquely suited to the icy Arctic, while societies in tropical regions adapted to monsoon cycles and abundant biodiversity. The availability of resources, shaped by prevailing climate, has long determined not only what people eat and build, but also how they think, worship, and relate to one another. Over time, these adaptations become woven into the fabric of culture, passed down from generation to generation as stories, rituals, and shared wisdom. The environmental impact of ancient civilizations, in turn, fed back into their surroundings. The Greeks and Romans, for example, left their mark on the Mediterranean landscape through deforestation, agriculture, and overfishing. These changes are preserved in the layers of marine and terrestrial sediments, offering clues to how human activity has long been intertwined with the natural world. While ancient peoples lacked the scientific understanding we possess today, they were acutely aware of their dependence on the land and the ever-present risk of environmental change. Today, as we look back on the arc of human history, it becomes clear that the relatively stable climate of the Holocene provided a rare and precious foundation for civilization. According to experts, this stability allowed humans to settle, farm, and build societies of unprecedented complexity. Yet as the climate begins to shift once again, with new uncertainties on the horizon, the lessons of the past take on renewed urgency. The story of climate and civilization is a reminder that humanity's destiny has always been shaped by the natural world, and that our adaptability, ingenuity, and cooperation remain our greatest assets in the face of change. To understand the forces now shaping our world, we must grapple with the science of climate stress, an intricate interplay of natural and human-driven factors that set in motion disruptions echoing through landscapes, societies, and the web of life itself. Modern climate change, scientists widely agree, is being driven primarily by human activity. At its core lies a dramatic surge in greenhouse gases such as carbon dioxide, methane, and nitrous oxide. These gases are released when we burn fossil fuels for electricity, transportation, and industry, clear forests for croplands or pastures, and intensively farm the land. Such emissions have thickened the atmospheric blanket that traps heat near the planet's surface, sharply amplifying the natural greenhouse effect. Since the dawn of the Industrial Revolution, the concentration of these heat-trapping gases has soared to levels unseen in hundreds of thousands of years, fundamentally altering Earth's energy balance and setting the stage for profound and widespread warming. Yet, the story of climate stress is not written by humanity alone. Natural processes have long shaped the planet's climate, though their influence on current changes is subtle and often overshadowed by human activity. Orbital shifts in Earth's path around the Sun, fluctuations in solar energy, and the sporadic fury of volcanic eruptions have, over millennia, nudged temperatures up or down. But when scientists examine the evidence from recent decades, it becomes clear the magnitude and pace of today's warming cannot be explained by these natural drivers. The overwhelming consensus is that human activities are now the dominant force, accelerating and intensifying shifts that once unfolded over geological timescales. The consequences of this new era extend far beyond a gentle warming of the globe. Instead, they appear as a spectrum of climate-induced stresses, each carrying its own risks and ripple effects for civilizations and the ecosystems upon which they depend. Chief among these are extreme weather events, heat waves that shatter records, droughts that parch the land, floods that sweep away homes and hopes, and storms whose violence seems to grow with each passing decade. These events are no longer rare outliers. They are becoming more frequent, more intense, and, in many cases, more destructive. Consider heat waves. As global temperatures rise, episodes of extreme heat have multiplied, affecting both rural and urban communities. Scientists have documented a clear link between rising greenhouse gas concentrations and the increasing severity of heat waves, with some regions experiencing not only higher peak temperatures but also more prolonged and persistent heat. Such extremes strain power grids, threaten water supplies, and take a heavy toll on human health. Vulnerable populations. The elderly, the very young, and those with pre-existing health conditions are particularly at risk, as are outdoor workers and people living in poorly insulated homes. Droughts, too, are being reshaped by the warming climate. Higher temperatures increase evaporation from soil and water bodies, drying out landscapes and putting agriculture at risk. Scientific assessments reveal that, in many parts of the world, droughts are becoming longer, more severe, and harder to predict. This intensification jeopardizes food security, disrupts local economies, and can drive migration as communities seek more hospitable ground. In some cases, drought lays the groundwork for wildfires, which, once ignited, can devastate forests, destroy homes, and send plumes of smoke drifting across continents. At the other extreme, the atmosphere's newfound warmth allows it to hold more moisture, setting the stage for heavier downpours and more frequent flooding. Where once a heavy rain might have soaked fields and filled rivers, now it is more likely to overwhelm infrastructure, inundate neighborhoods, and trigger landslides. These floods not only threaten lives but also spread disease, contaminate drinking water, and leave lasting scars on both urban and rural landscapes. The reach of climate stress extends beyond the immediate destruction of extreme events. Scientists warn that this cascade of impacts can undermine the foundations of society in subtler but no less dangerous ways. Crops wither in the heat or rot in flooded fields, reducing yields and driving up food prices. Fisheries suffer as warmer waters disrupt breeding cycles and push species toward the poles or into deeper, cooler seas. Water supplies dwindle as glaciers retreat and snowpacks shrink, threatening millions who depend on rivers for drinking water, irrigation, and industry. Ecosystems, too, are caught in the crosshairs. As temperatures rise and weather patterns shift, the habitats of countless species are transformed, sometimes beyond recognition. Plants and animals attempt to move in search of suitable conditions, but not all can keep pace. Sensitive regions such as coral reefs, mountain ecosystems, and the Arctic face especially high risks, with extinction looming for species unable to adapt or migrate. As species disappear or shift their ranges, the delicate balance of ecosystems unravels, threatening the services they provide: clean air and water, pollination of crops, and resilience against disease. The toll on human health is multifaceted. Heat waves can cause spikes in heat-related illnesses and deaths, particularly in cities where concrete and asphalt trap the sun's energy. Drought and flooding can degrade water quality and sanitation, fueling outbreaks of waterborne diseases. Changing climates may expand the reach of disease, carrying insects, introducing malaria, dengue, and other illnesses to new areas. Health systems, especially in lower-income regions, can quickly become overwhelmed by the surge in cases and the destruction of infrastructure. The economic costs of climate-induced disasters are substantial and rising. Billion-dollar disasters, once rare, have become more common in some countries, with hurricanes, wildfires, and floods exacting a high price in lost livelihoods, damaged infrastructure, and disrupted supply chains. Insurance markets strain under the weight of repeated payouts, and governments are forced to divert resources from long-term development to emergency response and recovery. The impacts are not evenly distributed. Marginalized and vulnerable communities often bear the greatest burden, whether because they live in flood-prone areas, lack the means to adapt, or depend directly on natural resources threatened by climate change. The stress of repeated disasters can fuel social tension, strain governance, and in some cases contribute to conflict or displacement. Looking ahead, scientists project that, unless greenhouse gas emissions are sharply curtailed, these stresses will only intensify. The world is likely to see not just a continuation, but an escalation of extremes: longer and hotter heat waves, more severe droughts, heavier downpours, and rising seas that threaten coastal settlements. These changes will test the resilience of societies and ecosystems alike, demanding adaptation at every level. Yet while the challenges are formidable, the science of climate stress also offers a roadmap for action. By understanding the causes and manifestations of these disruptions, by recognizing the fingerprints of human activity and the vulnerabilities of natural and social systems, societies can better prepare for what lies ahead. The future, though uncertain, need not be one of unrelenting crisis. With foresight, adaptation, and a commitment to reducing emissions, it remains possible to limit the damage, protect the vulnerable, and chart a new course through the storms of a changing climate. Across the millennia, civilizations have been tested and shaped by the pressures of climate. How societies respond to these challenges can mean the difference between endurance and collapse. The story of humanity's relationship with environmental stress is not a simple tale of defeat or triumph, but rather a tapestry woven from threads of innovation, resilience, migration, and, at times, tragic self-destruction. History offers a rich archive of civilizational responses to climate stress. In the fertile valleys of ancient Mesopotamia, the first city-states thrived by harnessing the power of rivers and seasonal floods. Yet these same societies serve as a cautionary tale. Overexploitation of renewable resources such as water and arable land gradually eroded the very foundations of their prosperity. Over time, irrigation systems became clogged with salt, soils lost their fertility, and harvests dwindled. Research indicates that this pattern of resource depletion contributed significantly to the collapse of once mighty societies, including not only those in Mesopotamia, but also the Mayan kingdoms of Mesoamerica and the Polynesian cultures that flourished on remote islands. These collapses were rarely caused by climate alone. Rather, it was the interplay of environmental stress with social, economic, and political vulnerabilities that proved fatal. Civilizations have also been undone by abrupt and sometimes catastrophic environmental shocks. Droughts, plagues, and volcanic eruptions have left indelible marks on history. The Hittites, one of the great powers of the Late Bronze Age, saw their empire unravel in the wake of prolonged drought and the social upheaval that followed. The Roman Empire, too, was not immune. Historical accounts and paleoclimatic evidence link episodes of drought, pestilence, and even distant volcanic eruptions to periods of instability and decline. Such events disrupted food supplies, strained governance, and sometimes triggered migration or conflict. Historians believe that the collapse of societies at the end of the Bronze Age was hastened by a combination of environmental and social stresses. Yet the story of civilization under climate stress is not solely a chronicle of ruin. Many societies have demonstrated remarkable resilience. Communities often adapted, drawing on local knowledge, culture, and ingenuity to weather environmental challenges. In ancient Egypt, for example, the so-called 4.2 kiloyear event, a period of pronounced aridity, forced the reorganization of political systems and economic practices. Historical records show that Egyptians responded by centralizing grain storage and distribution, developing new administrative structures, and investing in irrigation infrastructure. At other times, societies coped with erratic Nile floods, sometimes triggered by distant volcanic eruptions, by refining their understanding of the river and its patterns. Patterns emerge when examining different eras and regions. Civilizations often flourished during sustained periods of warmth and moisture, when crops grew abundantly and populations expanded. Conversely, periods of climate downturn marked by cooling, drought, or unpredictable weather frequently coincided with social strain. The Akkadian Empire in Mesopotamia, the city of Angkor in Southeast Asia, and many others suffered sharp reversals when climate shifted against them. In each case, paleoclimatic evidence, such as lake sediments, tree rings, and speleothems, points to multi-year droughts or floods that overwhelmed existing systems. However, the relationship between climate and civilization is neither mechanical nor inevitable. While some societies collapsed in the face of environmental stress, others persisted or even thrived by adapting. Archaeological research in the western United States, for instance, reveals that prehistoric societies responded to drought in diverse ways. Some communities endured by shifting settlement patterns, diversifying food sources, or developing new technologies. Others chose or were forced to abandon their lands and migrate. The lesson from these case studies is clear: collapse is not a foregone conclusion. Persistence, mobility, and innovation can offer alternative paths. Migration has long been a powerful response to environmental change. From ancient times to the present, people have moved in search of water, food, and safety. Environmental historians note that climate migration is distinct from political or economic displacement, though the boundaries often blur. When drought or floods rendered lands uninhabitable, families and entire communities sometimes undertook epic journeys, seeking new opportunities elsewhere. The drivers and forms of climate-induced migration are complex, shaped by local conditions and broader political or economic forces. Modern research underscores that migration can be both a last resort and a proactive adaptation strategy, helping societies avoid collapse and spread risk across regions. The success or failure of adaptation often depends on more than just the environment. Social structures, political institutions, and inequalities can amplify or buffer the effects of climate stress. Analysis of 5,000 years of societal collapse reveals a pattern. Societies with high inequality, rigid elites, or brittle institutions are often more vulnerable to environmental shocks. In contrast, flexible, cooperative, and inclusive societies tend to fare better. Anthropological research on ancient skeletons and settlements supports this view, showing that mobile and cooperative groups, those able to shift strategies, share resources, and make collective decisions, were more likely to persist during hard times. Culture itself shapes the way societies respond to climate threats. United Nations, educational, scientific, and cultural organizations and other organizations have highlighted the value of indigenous knowledge and local heritage in enhancing climate resilience. Around the world, community-led adaptation efforts draw on time-tested practices, traditional water management systems, drought-resistant crops, and sacred conservation sites are all examples. In Ghana, for instance, ancient farmers cultivated crops resilient to drought, while in the American Southwest, the Zuni developed intricate irrigation systems to make the most of scarce water. These practices reflect a deep understanding of local ecosystems and the ability to innovate within cultural traditions. Heritage and culture are also under threat from modern climate change. Rising seas, intense storms, and shifting weather patterns endanger historic sites and cultural landscapes. Experts argue that integrating cultural heritage into climate adaptation efforts is essential, not just to preserve the past, but to inspire creative and inclusive solutions for the future. Local and indigenous stewardship can provide models of sustainable land use and ecosystem management, helping communities adapt while maintaining their identities. The concepts of vulnerability and resilience are central to understanding civilizational responses to climate stress. Vulnerability is shaped by exposure to hazards, sensitivity to change, and the capacity to adapt. Resilience, meanwhile, is the ability to absorb shocks, reorganize, and continue functioning. Societies that successfully adapt to environmental stress tend to be those that anticipate change, learn from experience, and invest in social cohesion and flexible institutions. Analyses of past societies, as well as assessments by the Intergovernmental Panel on Climate Change, underscore the importance of viewing vulnerability and resilience as dynamic, interrelated processes within complex social ecological systems. Land use, agriculture, and ecosystem services play a crucial role in the story of adaptation. Throughout history, people have modified landscapes to buffer themselves from climate extremes, terracing hillsides, constructing canals, and managing forests. These interventions can enhance resilience, but they can also introduce new vulnerabilities if not managed sustainably. Lessons from ancient farmers, whether in Africa, Asia, or the Americas, inform modern strategies for coping with a changing climate. The wisdom embedded in agricultural traditions, water management, and cooperative governance remains relevant as current societies face renewed environmental challenges. Despite the many examples of collapse, historians point out that global, simultaneous civilizational collapse is unprecedented. While environmental change has toppled powerful empires and transformed societies, human adaptability and ingenuity have often prevailed. The future remains uncertain, but the past offers both hope and warning. By learning from the successes and failures of those who came before, societies today can chart paths toward resilience, justice, and sustainability in the face of climate stress. The 21st century has brought civilization to a new and precarious stage, where the climate is no longer just a backdrop to human progress, but a central force shaping the fate of societies. The scientific consensus is clear. The planet's climate is changing at an accelerated pace, and the impacts are already rippling through ecosystems and human communities. Looking ahead, scientists warn that the stresses imposed by climate change will test the resilience of modern civilization in ways that are both profound and unpredictable. Current projections, synthesized in the latest assessments by the Intergovernmental Panel on Climate Change, point to a rapidly warming world. If emissions continue on their present course, global average temperatures could rise well beyond the threshold considered safe for both human society and the natural world. The physical science is unequivocal. Continued warming will bring more intense heat, shifting rainfall patterns, rising seas, and more frequent extreme events. These environmental changes are not distant threats. They are already visible in shrinking glaciers, altered growing seasons, and increasingly destructive storms. For many people, especially in vulnerable regions, climate change is now a lived reality, not just a scientific projection. The consequences of these shifts reach far beyond the weather. Climate change acts as a crisis multiplier, intensifying existing challenges and creating new ones. Food and water security, for example, are under growing threat as droughts, floods, and shifting seasons disrupt agriculture and strain freshwater resources. In some regions, entire livelihoods are at risk, with farmers and fishers finding it harder to predict the conditions they depend on. Urban centers, hubs of economic activity and population, face the prospect of more frequent heat waves, water shortages, and infrastructure failures. The economic damages from these impacts are mounting, and the costs of inaction are projected to rise sharply in the coming decades. Perhaps most troubling is the possibility that climate change could interact with other social and environmental stressors to destabilize society on a much larger scale. Scholars reviewing the literature on collapse have noted that while climate change alone does not guarantee societal unraveling, it can act as a powerful catalyst, especially when combined with political fragility, economic inequality, or resource depletion. In the most severe scenarios, unchecked warming could tip the balance, overwhelming the adaptive capacity of even well-resourced societies. Some researchers have explored the potential for cascading failures, where impacts in one sector, such as agriculture, reverberate through food systems, markets, and political institutions, amplifying risks and increasing the chance of widespread disruption. While global, simultaneous collapse is considered unlikely by most scholars, the risk of severe regional crises or even the breakdown of complex societies in especially vulnerable areas cannot be dismissed. Warnings from global leaders and scientific bodies underscore the gravity of the challenge. The United Nations and leading climate scientists have described climate change as the greatest threat facing modern humans, a crisis that touches every aspect of life and demands responses on an unprecedented scale. The call for action is not just about avoiding distant catastrophe, it is about safeguarding the foundations of civilization, food, water, security, and social cohesion against pressures that are already unfolding. Yet, while the risks are daunting, humanity's future in a changing climate is not predetermined. The scientific community emphasizes that there are pathways to resilience and that the choices made today will shape the range of futures available to generations to come. Building resilience means more than just weathering the next storm. It involves rethinking how societies organize, invest, and cooperate in the face of new and evolving risks. Adaptation lies at the heart of this effort. As the impacts of climate change become more pronounced, the need for societies to adapt, to anticipate, absorb, and recover from disruptions has never been more urgent. Adaptation takes many forms, from constructing seawalls and drought-resistant infrastructure to redesigning urban spaces and reimagining agricultural practices. Each adaptation strategy must be tailored to the specific challenges and vulnerabilities of different places and communities. For fragile and conflict-affected regions, this means overcoming unique barriers such as weak governance, limited financial resources, and ongoing instability. In these settings, adaptation is as much about strengthening institutions and social networks as it is about technology or engineering. But adaptation alone will not suffice if it is not matched by efforts to address the root cause of climate stress, greenhouse gas emissions. The window for avoiding the most dangerous consequences is narrowing, and the latest scientific assessments reiterate that only sharp, coordinated reductions in emissions can stabilize the climate over the long term. This dual challenge, adapting to impacts while reducing emissions, requires a scale and speed of action that is historically unprecedented. One of the most persistent lessons from research is that effective responses to climate stress demand global cooperation. Climate change knows no borders. Emissions released in one country affect the entire planet, and the impacts of warming are felt worldwide. International cooperation is therefore not a luxury, but a necessity. Financial assistance, technology transfer, and coordinated policy are essential to ensure that all countries, especially those with fewer resources, can adapt and mitigate effectively. Past international agreements, such as the Kyoto Protocol, have shown that global efforts can deliver measurable results, but scientists and policymakers agree that far more ambitious and inclusive cooperation will be needed to meet the scale of the crisis. Knowledge sharing is another crucial ingredient. The challenges posed by a changing climate are complex and interconnected, cutting across sectors and disciplines. International agreements and institutions play a vital role in facilitating the exchange of expertise, data, and best practices. Coordinated research can accelerate the development and deployment of new technologies, and lessons learned in one context can inform adaptation efforts elsewhere. Technological innovation stands out as a source of hope and possibility. Emerging technologies are already beginning to transform the landscape of climate adaptation and resilience. Artificial intelligence and big data analytics, for example, enable more precise forecasting of extreme weather and better management of resources such as water and energy. Drones and Earth observation satellites provide real-time monitoring of environmental changes, helping communities prepare for and respond to disasters. The Internet of Things, networks of interconnected sensors can track everything from soil moisture to urban air quality, offering early warnings that save lives and reduce losses. Beyond monitoring and prediction, technology is reshaping how societies build resilience. Advances in materials science, such as batteries that store renewable energy more efficiently or transparent wood for energy-efficient construction, hold promise for reducing the carbon footprint of buildings and infrastructure. In cities, digital solutions are enhancing the ability of planners to assess risks, design flexible systems, and coordinate emergency responses. For rural and agricultural communities, climate-smart technologies can improve yields, conserve water, and reduce vulnerability to drought or pests. These innovations are not just tools for adaptation. They represent a significant economic opportunity. Analysts project that demand for climate resilience and adaptation technologies could create a trillion-dollar market by 2030, spurring investment and job creation alongside environmental benefits. The challenge, however, is to ensure that these technologies are accessible and affordable for all, especially those most at risk from climate impacts. As societies look to the future, the importance of resilience cannot be overstated. Building resilient societies means investing in systems, physical, social, and economic, that can withstand shocks and recover quickly. It means fostering strong institutions, inclusive governance, and robust social safety nets. It also means recognizing the limits of technology and policy, and embracing humility, learning, and flexibility in the face of uncertainty. The future of civilization in a changing climate is a story of risk, but also of possibility. The stresses imposed by a warming world are immense, but so too is the human capacity for innovation, cooperation, and adaptation. The path forward will demand courage, vision, and above all, an unwavering commitment to work together, across borders, sectors, and generations, to safeguard the foundations of civilization for the challenges that lie ahead.